Question 1. Correct answer. 1. Explanation. The pattern is a simple arithmetic progression. The number of dots inside the square increases by 1 in each step. 1, 2, 3, 4. Therefore, the next figure must contain 4 dots. Question 2. Correct answer. 2. Explanation. The figure's complexity increases in each step by adding a new set of lines. Question 3. Correct answer. 4. Explanation. 2 patterns are occurring simultaneously. Central circle. The large circle in the center alternates between being filled and empty. The sequence is filled to empty to filled. The next must be empty. Small dot. Question 4. Correct answer. 4. Explanation. This is an analogy problem. Figure 3 is a square, and adding an inward-pointing triangle to one of its sides results in figure 4. Question 5. Correct answer. 3. Explanation. The pattern involves the number of sides of the outer shape. Question 6. Correct answer. 1. Explanation. There are 3 distinct patterns. Position. Question 7. Correct answer. 1. Explanation. This problem features 2 inverse patterns. The number of S letters decreases by 1 each time, 4 to 3 to 2 to 1. The number of circles increases by 1 each time, 1 to 2 to 3 to 4. The correct figure must have 1 S and 4 circles. Question 8. Correct answer. 2. Explanation. 2 patterns are at play. Question 9. Correct answer. 2. Explanation. This is a simple alternating series. Figure 1 and Figure 3 are identical. Therefore, Figure 4 must be identical to Figure 2. Question 10. Correct answer. 2. Explanation. The clearest pattern is the letter in the central triangle. The alphabetic gap between the letters increases by 1 each time. G to H plus 1 letter, H to J plus 2 letters, I and J. J to M plus 3 letters, K, L, and M. The next central letter must be M. Option 2 is the only one with M in the center. Question 11. Correct answer. 1. Explanation. The top and bottom panels follow separate patterns. Top panel. The number of lines increases by 1, 1, 2, 3, 4, and their orientation alternates. Vertical, horizontal, vertical, horizontal. Bottom panel. The number of lines increases by 1, 2, 3, 4, 5, and their orientation alternates. Horizontal, vertical, horizontal, vertical. The answer must have 4 horizontal lines on top and 5 vertical lines on the bottom. Question 12. Correct answer. 4. Explanation. The small line segment connected to the center dot rotates 60 degrees clockwise in each step, pointing to the next vertex of the inner hexagon. The next position is the vertex on the right. Question 13. Correct answer. 4. Explanation. There is no consistent logical pattern between Figure 2 and Figure 3. New elements are introduced while old ones reappear in different positions, breaking any simple sequence of movement, rotation, or transformation. Question 14. Correct answer. 1. Explanation. This is another alternating series. Figure 1 and Figure 3 are the same. Therefore, Figure 4 must be a repeat of Figure 1. Question 15. Correct answer. 4. Explanation. This is an analogy problem where the transformation is a vertical reflection, flipping upside down. Figure 2 is the vertical reflection of Figure 1. Applying the same transformation to Figure 3 gives you Figure 4. Question 16. Correct answer. 3. Explanation. The most logical pattern is dots. Question 18. Correct answer. 3. Explanation. 2 patterns are present. Symbol. Inside, the progression of shapes is based on the number of points. Dot 1 point. Line 2 points. The next logical shape would have 3 points, which is a triangle. Symbol below, a new, unique geometric shape is introduced in each step. The next figure requires a new shape, like the square shown in the options. Question 19. Correct answer. 3. Explanation. Line position. The line segment rotates 60 degrees clockwise to the next vertex in each step.
Look at numerical progression. The real foundation is, well, arithmetic growth. If you look at the key for question 1, the one with the dots inside a simple square, the rule is just a classic linear progression.
For example.
The number of dots increases by exactly 1 in each step. So you see 1 dot, then 2, then 3, then 4.
That's the easiest one, yeah. Kind of the warm-up pitch. But the sources show these tests ramp up really fast. Like, consider question 22. Now, this is still numerical progression, technically, but it demands you recognize a deeper mathematical structure. Here, the number of small circles follows the sequence of what mathematicians call triangular numbers.
Triangular numbers. Okay, that's a massive cognitive jump from just adding 1. Explain what that means for someone, maybe seeing it for the first time.
Well, it means the increment itself is increasing systematically. You start with 1,
okay.
Then you add 2 to get 3, then you add 3 to get 6, and the required answer in that question was 10, which meant you needed to add 4 next.
Ah, right. So you're not looking for just adding the same number each time.
Exactly. You aren't looking for a fixed addition. You're looking for the sum of sequential integers. You have to recognize that the rate of change itself is following a simple arithmetic progression. Plus 1, plus 2, plus 3, plus 4.
Got it. So if you're just counting the items, you fail. But if you're looking for the pattern in how much it increases, then you succeed.
Precisely.
Okay. Now let's pivot slightly to movement. The second sort of foundational rule seems to be consistent rotation. The source keys identify fixed angle rotation like everywhere.
Oh, yeah. Take question 12, for example. There's a figure with a small line inside a shape. That little line segment rotates exactly 60 degrees clockwise in each step. Boom, 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 hitting the next vertex of the inner hexagon. Super predictable.
Fixed angle, fixed direction. Like a simple clock.
Yep.
But, fixed rotation can get a bit boring, right? Here's where it gets really interesting, I think. Compound movement. Look at the solution for question 35, the one with that cluster of dots cycling through the quadrants. The movement itself seems to have a dual function.
It does, absolutely. So the dot cluster rotates 90 degrees clockwise to the next quadrant. That part's a simple fixed angular move, just like the clock. But triangular numbers in question 22. The challenge isn't usually that the rules themselves are impossibly complex. It's spotting the combination of simple rules.
Right, rules based on position or quantity or maybe hidden math.
Which brings us to a final, maybe provocative thought to leave you with. If these test systems are designed to be entirely logical and the main challenge is just spotting that hidden combination of 2 or 3 simple independent rules, well, what real-world systems out there, maybe in finance, maybe in social trends, maybe in the masses of data we see every day, what systems might we be incorrectly assuming are random or chaotic, when in fact, they could simply be following an unseen combination of just 2 or 3 independent, simple, logical rules that we haven't quite dissected yet?
Something to think about. Keep deconstructing those figures out there. Until next time, keep digging deeper.